So, first of all, just a quick little bit of history here. When I met these two guys, I had been in academia for 15 years, was a tenured full professor. And in the year 2000, I made the decision I was going to leave academia and leave that comfortable world behind, guaranteed salary, pension benefits, everything else, and strike out on my own. And I'd already been doing a bit of consulting, and we were ranching, and we'd already been playing around with the grass-fed deal, and that's just when this whole grass-fed deal was starting to really gain some traction. And so when I left the university in 2000, I was determined that I was going to try to find the very best grass-based genetics that I could find anywhere. And so I spent, over the next 3 years or so after that, an inordinate amount of time on the road. Sometimes I was gone 30, 35 days at a time on these trips trying to find cattle. And I was looking for something very unique. I wasn't looking for the mainstream cattle. And at that time, in the year 2000, EPDs were the big deal, and a lot of people were doing what I call paper breeding. They were just breeding on paper, making their whole mating decisions based on the EPDs on paper, which, by the way, don't do that. That is a huge, huge mistake. Okay, if you try to do that, you will take yourself down a road of no return. So I started inquiring about people that had the phenotype, specifically phenotype. I started asking people all over the country about a very specific phenotype of cattle. And these were two of the guys that were referred to me. They had no clue who I was. I had no clue who they were. But we connected, and I went out to both of their ranches as well as a number of others. And when I found what I saw there, what I learned, number one, was it didn't take 5 minutes after stepping on a ranch and looking at their cattle to know whether they were a breeder I wanted to work with or not. Literally within 5 minutes, I would know that. And these two guys, I knew that immediately. And like Gene said, when we went out there and visited first, then we came out later and ultrasounded his cattle. And when I laid the probe on those cattle, I didn't even have to look at my machine after a while, because every one was just like the other. And that was astounding to me, because that was so rare in our industry, that you had cattle that were truly, you hear people talking about peas in a pod, but that's what I found. Then I went out to Mark's and found a very, very similar situation. And I can say that, from that point forward, their cattle, their bloodlines have been very important in the grass-based and grass-fed sector. So what I want to do, though, is introduce to you something that's just a little bit different, and it's something that you need to pay attention to in your breeding programs, and that's epigenetics. How many people in the room have ever heard of epigenetics? Okay, so when I was with the university, I'm formally trained as a geneticist and a reproductive physiologist. So that's what I taught when I was teaching at the university, and that's what I did a lot of research in. But at that point in time, by the year 2000, epigenetics was not really a field of study. It wasn't something that we were acutely aware of. So as we look at epigenetics, what we find is that the formal definition, it's a study of changes in organisms caused by modification of gene expression rather than alteration of the genetic code itself. So what does that mean in layman's terms? What it means is this. Genes come in pairs, right? And every pair of genes codes for something. Very simply, if we look at qualitative traits like eye color, hair color, that type of thing, We have genes that code for our eye color, our hair color. So do cattle. But we also have genes and many pairs of genes, the quantitative traits that band together to code for things like weaning weight and yearling weight and fertility and marbling and all of those other things. But you know, those genes, they can either express themselves a little bit, or they can express themselves fully, or anywhere in between. That's gene expression. So it's just like if I have blue eyes, I could have genes that code for very bright, dark, deep blue eyes, but epigenetics, this alteration, could influence that degree of expression, and instead I might end up with pale blue eyes. Okay? So that's what epigenetics does. And what causes these epigenetic effects that alter the way that genes can express themselves in an individual? Well, it's any kind of environmental factor. So really, epigenetics means the impact of environmental factors on the degree of gene expression in an individual. So epigenetics impacts every one of these living organisms here. So anything that has DNA can be impacted by epigenetics. Now, in our soil health academies, we teach 3 basic principles. And the first of those principles is what we call the principle of compounding. And very simply, what that means is that everything creates a series of compounding and cascading effects. In biology and nature and in life, there are never any singular effects, ever. Now, we are trained to think that way, and we think that way, but that is not the case. So every decision that we make, every management practice that we apply, actually causes a whole series of compounding and cascading effects. And these compounding and cascading effects can last for weeks, for months, for years, or even a lifetime. So we have to seriously consider that. So it's the exact same way with epigenetics. With epigenetics, we can have a series of compounding and cascading effects that last not only for the current generation, but epigenetic effects can be passed down to the next generation and the next generation. So the decisions that we make today, including the pesticides that we use, okay, including the drugs we give, the vaccines and whatever we give our livestock, including the supplements that we feed them, all of that can create epigenetic effects that last not just in the direct individuals that are impacted that day, but in their future offspring. But also on our farms and ranches, we can create epigenetic effects, either positive or negative. So just like with compounding effects, they can be positive or negative. With epigenetic, they can be the same way, either positive or negative. So we can create, not just in our cattle, but in any other species of livestock, in our plants, that means all of our grasses and forages that are growing out there, in our row crops, in microbes in the soil, in the insects, pollinators, all of these other things. Again, they all have DNA, and every one of them can be impacted with either positive or negative epigenetic effects. So epigenetics affects all of our farm animal species, plants, insects, wildlife, and yes, even us. And what creates epigenetic effects? Well, some of the negative epigenetic effects are created by things like exposure to toxicants, nutrients. Now, we think all nutrients are good, right? You know, a lot of the supplements that we use, folks, can actually create some negative epigenetic effects. Infectious agents, all of those types of things. And again, it can create transgenerational effects and impact future generations. Research has shown that germline epigenetic transgenerational inheritance has been shown in plants, insects, worms, humans, and so forth, and even traced all the way to the F3 generation. So what are some of the things that impact and create negative epigenetic effects? Well, pesticides that we use. And guess what? Herbicides. Okay? Now the herbicides, again, compounding effects. So I use a herbicide, and then I can create negative epigenetic effects in my plants that are growing in my soil, in the microbes that are in my soil, in the macroorganisms, the earthworms, the beetles, and all of the other insects that are in contact with that soil, and then my livestock that are eating those plants to which the herbicides were just applied. Same thing with any of the pesticides that we may use. Hybrid vigor, and Gene and Mark both talked about this, hybrid vigor can actually create positive epigenetic effects in individuals, and you get even greater positive epigenetic effects by far when you use line-bred sires in your commercial cow herd, because you get an explosion, heightened heterosis or hybrid vigor that creates those positive epigenetics. Now let's give you some other examples. Now this may surprise you. When I was with the university, and even for a number of years after I left, again, I was a geneticist and a reproductive physiologist. And I did about everything that you could do in terms of reproductive physiology and reproductive technologies. So I did tons of AI research and estrus synchronization research. I even wrote and produced the estrus synchronization pamphlets for a number of years for ABS. So I was heavily involved in all that. I did everything you could do in embryo transfer. Not just routine embryo transfer, but I did follicular oocyte aspiration, cloning, in vitro fertilization, DNA sexing of embryos, and even embryo splitting or micromanipulation of embryos. So I did all of that. But in those days, do you know what I noticed? I noticed that in the event of doing all of this, 80% of the time, and sometimes even more than that, the calves that were produced out of these reproductive technologies were never as good as their natural sired mates. The natural sired mates were better, and a much higher percentage of the time they were better than the ones that were ET calves and AI calves. And at that time, I didn't understand why, what was really creating or causing that. Now we know that's an epigenetic effect. So why? Why does that occur? Because the manipulation that we're doing to that semen, to those embryos, to those eggs, that manipulation can create negative epigenetic effects. And it's transgenerational. That's why a lot of times ET-sired heifers, even their calves, are never as good as the naturally bred. So it is something that we have to keep in mind. Now, does that mean that every time that you have some significant negative epigenetic effects? No, it does not. But what it does mean is that you most certainly run that risk. And you've got to keep that in mind in your genetic selection. So epigenetic effects impact the health of individuals, their fertility, their milk component production, calf lifetime performance, longevity and soundness, even their ability to be able to resist internal and external parasites. 9 times out of 10, cattle that are much more susceptible to internal and external parasites, they're more susceptible because they experienced a negative epigenetic influence. somewhere along the way, either in utero or after they were born. And it affects endocrine system functioning, which if you impact that negatively, then that negatively impacts everything else listed above there. Another epigenetic effect that we have found is in dairy cattle. We now know that if you leave heifers on their dams in a dairy, those heifer calves will perform better lifetime than what's the normal in a dairy? All right, calves are removed, within 48 hours, right? Boom, they're gone, they're off their mother, and she never has any more responsibility for them, and then they're raised by a formula. But now we know that if they're raised on their dam, and you can still run them through the milking parlor and milk them, we have a lot of dairies doing that now, they will perform far better lifetime. That's a positive epigenetic effect, and being removed from their dam and being basically, quote, bottle raised and bucket raised is a negative epigenetic effect. So what we do matters. What we do matters quite a bit. Again, it affects everything. All the way up to us, translates up to us. And by the way, there's quite a bit of research. Do you know that a lot of the dementia and neurological issues that we're facing today and the significant rise is due to negative epigenetic effects? And actually, Nina's talk last night, in reality, what she was really talking about, without knowing it, was epigenetics. That's what's creating the issues that she presented last night. And those negative epigenetics are being created by what? By our poor diet. By our very poor diet and not getting enough good fats. So again, chemicals that we use, even our fertilizers, okay, even synthetic fertilizers can create negative epigenetic effects. We even have issues with our microbial population, some of the supplements, so we have to consider that, and again, the reproductive technologies. So to finish up, there are several things that we can do to help assure that we can create some very positive epigenetic effects with our livestock, with our plants, with our soils, and even with us. So first of all, in our farming and ranching, we need to be heavily concerned about producing complexity and diversity in our plant species. Monocultures actually encourage negative epigenetic effects. And again, in a compounding way, we get negative epigenetic effects with monocultures from everything from the microbes in the organisms that live underneath the soil, all the way up through our plants, through our birds, through our wildlife, through our livestock, and through us. So by having far greater complexity and diversity in the plant species that are out there, we can actually reverse that, and we can produce very positive and transgenerational epigenetic effects. By the way that we graze, this is why adaptive grazing is so important. The very nature of the way that we graze and forage our livestock has a profound impact on whether we're going to produce positive epigenetics or negative epigenetic effects. So again, what we do, folks, the decisions that we make on an everyday basis and the practices that we implement on a daily basis actually do matter, and they matter for more than that day. They matter for the next year, they matter for the next generation, and then the next generation. So if we keep that in mind and we ask ourselves that question every time we make a decision, then we'll be far better prepared to be able to make the right decisions that are going to help us to be able to produce positive rather than negative epigenetic effects.